Did you hear that bleep?
No,
Right, it's recording from now, okay?
go.
All right. I've had a request from this guy called Geist View. And I'm going to read to you what he says, and then I'm going to ask you a couple of questions because you know the answers that I don't know. And if you could just answer them honestly, then I can go back to the Geist View guy and say, right, I don't know, but I've asked these questions. These are the answers. Okay, so he says, I said, Geist View, as far as I can tell, a sextant works on both models. So he's responded and said, then you should be able to tell me how, right? So can you just tell this guy how they work on both models? A nautical sextant?
Right. When they take a sighting from a star, all right, all the navigator knows is that the star will be at a certain angle from a certain point on the Earth, and then plots his course. All right. The angles all calculated are based on a plane surface, plane, plane surface.
Right.
All right. And the navigators are told it works. We know you live on a ball, but the angles for a plane surface will get you from A to B. All right, they're exactly the same. A sextant, all a sextant does is tells you this body, this moon, the sun, these stars will be at this angle when you are at this position on the Earth.
So you know this because you've. Just tell me how you know this stuff, just so that guys you can't turn around and say something like, "Who the hell's this guy?" Just tell me a little bit about how you know this kind of stuff to be true.
Right, right. I taught for the Duke of Edinburgh's awards scheme for a number of years, okay, and one of the things we taught was map reading, okay. I also sailed years ago, all right, so I've done some naval navigation,
Okay.
okay. I know how to read a sextant, all right. I understand the maths that goes into a sextant, and I also understand how we navigate by the stars.
What was
Right,
the thing that you said that you also know how to use plan?
planisphere.
Just yeah. What? Just elaborate on that.
A planisphere is a flat map of a spherical surface. Okay, but in the same way that the flat circular map of the world is being wrapped around a ball, that's exactly what they've done with the skies. So all a planisphere does is takes what people think is the celestial sphere and put it back on a flat map. All right, and it works.
Oh,
Okay, it shows how the heavens rotate, it shows how the sun rotates, how the moon rotates, and it tells you what will be where and when it will be there.
I said to him that I've not found any reason why it cannot work on a flat as opposed to a plane,
Yeah.
as it seems to work on both.
Okay.
And
Well,
he, and then he said I didn't ask how it didn't work. I asked how it did work on a ball.
how it works on a ball.
Well,
Well,
how he asked how. He's emphasised the word how.
because all they've done is they've wrapped the map round a ball.
So
Okay.
basically, it's backwards engineering it from back to what it used to be.
No, because it never was a ball. All right. They've taken the ground. They've taken the sky. The sky could well be flat. I've not this dome thing. I think is a bit of a. I think we've missed a beat on that.
I think the sky looks flat to me.
Yeah, and there's no reason why the sky shouldn't be flat.
Okay, so the next thing that he says is I said the sextant works because of the mapping of the stars, and he said wrong. Let me know when I can do star readings in the daytime.
You can't use the sun during the daytime.
Okay, I said not because of the shape of the Earth, and he just said wrong again. So then I said I must be missing something because a sextant works on both models, and he said wrong. Kind of hard to do when you need two poles and two pole stars, i.e., Sigma Octantis and Polaris. Not only that little problem, you also need two hemispheres, and just to rub it in requires the sun's angular size to never change size, and that's just a start. But do continue. Is he right?
No, he's not, because we don't live on a ball, so there are not two hemispheres to start with.
But why does he think that there is? Why does he think that there needs to be?
Because he thinks he lives on a ball.
Okay, so
That's the short answer.
I've said that I may be missing something, and I have no issue in admitting that it's not something I've ever considered until you asked. So you might want to point out why the mechanics do not work on a plane, as it does seem to work on both. And then his answer was, does the longitude and latitude lines on the flat Earth converge at a central point in the southern hemisphere? No. Then you have a problem.
There you go. Longitude and latitude are based on astronomical observations. That's where we've got the whole longitude and latitude grid from. Okay? And they're all just angular constructions. Okay? So that when they're out in the ocean, they could navigate, because there's no points of reference. Okay? You don't go out, when you go out and follow a map, you don't point the compass and walk in the direction of the compass. You take a sighting, you find something the compass is pointing to, and you walk to that point. All right? And you can't do that on the oceans. So what they have to do on the oceans is they have to use the sun, the moon, and the stars. Okay? That they were points that they could focus on. But the problem with the stars is they're all constantly moving, as are the sun and the moon. All right? So it makes the calculations are quite complicated, but they do work. They will tell people exactly where they are on the surface. All right.
So it's
and
not.
It's nothing more than a reference system.
So why does he think it's a problem if the latitudes and the longitudes converge at a central point in the northern hemisphere, but not in the south? Why does he think that's a problem?
Short answer: I have no idea. Yes, the star maps. Get a planisphere, all right, and you will see that the sky has got longitude and latitude lines just the same as on the Earth below.
So then, if it makes sense,
and they converge at the North Pole, they converge at Polaris, and they work perfectly. The sky rotates. The sky rotates like a disc above the Earth.
So basically, he's got a misconception. Is that right?
Yeah, you can do exactly the same things with the stars on a sphere as you can with the stars on a flat surface. The only difference between the two is there a single point for the South Pole? All right. Antarctica is locked down. We're not going to go there and find out. Okay. For the stars, their trump card is Sigma Octantis, which is nonsense. All right. There is no South Pole star.
I agree with that.
Octantis is the constellation, all right, and it's a 3-star constellation that is claimed to rotate around the south celestial pole, all right, but nobody's seen it.
To be honest with you, my own personal view, I think the most likely consequence, or the most likelihood, is that the stars in the southern skies appear to be the North Star of a world below us. Because I don't believe that we are doing what they tell us we are doing, and the only other explanation for the stars in the south is that it's the North Star of a southern world that we're not meant to know is there. Moving on, there's only 2 more questions. In capital letters, this is probably his biggest point. This is what he's put. Explain how a sextant works on a flat Earth, especially in the model where the sun's angular size changes throughout the day. That's all in capitals, so he obviously wants to focus on that particular bit.
Right, you don't take a sun sighting based on its angular size, all right? You take a sun sighting based on its lower limb, which is the lower edge.
So
the angular size has got nothing to do with it.
So that's the answer done. Can we move on, or is it more complicated than that?
No, it's as simple as that.
And then he's put his last one is, you've conveniently left out how on a flat Earth where the sun's angular size changes throughout the day. All you said is that it does. So basically, it's got nothing to do with the angular size.
No.
And then he's put, I'll let you try again. Okay, so Geist view, I've tried again. I have admitted that I didn't know the answer, and I've gone to somebody that does know the answer, or certainly more than I do. So at least, if you disagree with me, at least I've gone and done what you asked me to do. I've explained to you how it works on a flat Earth model, or I've used it through agents. Somebody else has explained it to you. And if you don't accept that, at least debunk what I've just given you, because I don't know the answer. You've asked me to do something. I've now gone and done it. I've got your answers. Let's see what you say about it. Don't get me a text-heavy response. Do a video response in reply so I can take it in, because I'm a thick flat earther. Do a reasonable video in response like I've done for you, and then we'll see where we end up. But it appears from all angles that I can see that a sextant, a nautical sextant, works on both models equally, because it's got nothing to do with the angular size of the sun. It's to do with the position of the sun at the bottom of the sun throughout the day. That's it. So it seems to work both ways. It appears that you've got a misunderstanding about a nautical sextant based on whatever you've learnt. And if I've got it wrong, tell me. If I'm misunderstanding, tell me. Don't do it in text, do it in a video, because everybody that does anything in text is a footnote. We want it in video format so we can see how credible you are. Capiche?